In this video, I will go over p-bar. So p-bar is good for discrete data, right? So counted data. It's going to have a binary state, so it's either defective or it's not, pass or fail, and it deals with non-constant sample sizes. So the first thing we need to know is P, or proportion. So our proportion is going to be the rejected units divided by our inspected units, and we can autofill that down. My p-bar is going to be the sum of all of our rejected units divided by the sum of all of our sampled units. And so I can autofill that down. I'm going to use F4 to lock my references here and autofill down. Okay. So then my upper control limit. So as we can see here, we have two different ways of doing this. One is using the constant sample size. We don't have that. So we're going to use the not necessarily of constant sample size, so not constant. So for this one, we're going to take our p-bar, put this down here so everyone can see it. We'll take our p-bar, and I'm going to hit F4 3 times, so I'm going to lock that column, because I'm going to autofill that over, plus 3 times, and then I have the square root of p-bar again, F4 times 1 minus p-bar counting my brackets carefully here, divided by the square root of my sample size. All right. And then when I autofill that down, that will change because our upper and lower control limits will change based on sample size. And when I drag this one over, I just need to change that to subtract, because the lower control limit is the same formula. It's just subtract instead of add. And autofill down. Let's take a look here. And there we go. So we can see here we have one point that looks like it's above, one point is below. One way we can do this is we can use an OR function. An OR function, so we can ask, is the P greater than upper control limit, or is the P less than the lower control limit? And if either of those conditions are true, it will show up as true. So everywhere we have a true in these, that means that that P, for this one, it is greater than our upper control limit. And this one, it is lower than our lower control limit. I'll go ahead and color code those a little different for you. So those points would be exhibiting special cause variation. And we'll label this as a P chart. There you go.